All right, ladies and gentlemen, hello and welcome back to the only coast to coast radio show that's all about the information economy, new jobs, new roles, new business models, new ways of doing things. That's what we want to do here on Inside Analysis. Yours truly, Eric Kavanagh, here today with an industry legend, a veteran, folks. Tom Redman is with us from Data Quality Solutions. He's been writing in Harvard Business Review, among other places. And he, like me, believes that quality is of paramount importance in this new age of AI. Everyone's excited about using AI. Gen AI, of course, has all the headlines these days. That's just one flavor of artificial intelligence. And you have to remember the A stands for artificial. So, how do you give grounding to this AI engine? How do you give it your anchors of truth, as someone has described them to me? We're going to talk about that and the importance of good management. And you might like that, Tom. I said today on a show that good management is underappreciated and underestimated because good management is going to solve a lot of problems. And to be a good manager, you have to understand what you're trying to accomplish. You have to understand people. You have to understand process, and you have to stay calm. Right? You have to
Yeah.
stay calm and work through difficult situations with clarity. But Tom Redman, welcome to the show. Tell us
Yeah,
your latest mantra about data quality.
well, thank you very much for having me, Eric. And just to reinforce what you're saying, I mean, you're not going to get high quality data without good management. Uh, it's been true for 50 years. I guess that's about the length of time we've been citing garbage in, garbage out. The biggest change I've seen to that is big garbage in, big garbage out.
Yeah.
And it's particularly true with AI. Right now, it's not unfair to say a lot of AI models are models that no one trusts, or excuse me, models that no one understands, trained on data no one trusts. What could go wrong?
Yeah, right. That you make a really good point, and OpenAI, as they're called, is now closed. It's a closed model. It's a gigantic black box, right? So we
Mhm.
don't know what's inside. And let's be honest, the old rules of transparency and open source, for example, they still apply, but it's harder and harder. These models are incredibly complex. And so getting to the crux of how they make a decision is an extremely difficult thing, if not impossible. And so, what do you do in an environment like that? You have to have controls somewhere else, controls of what goes in, controls of who looks at what comes out. I know in the risk management world, it's all about control points, which can be someplace a person can take a decision or a machine, but knowing where they are, that's part of the magic, right?
Yeah. I mean, let me build on this. I had an experience a couple of weeks ago that, for my mind, really, sort of captures the essence of where we are. And involved, look, I'm a New York Yankee fan. I live in the New York metropolitan area, and they were playing the Cleveland Guardians in the series before the World Series, in the series to get to the World Series. And they went up 2-0. And I thought I heard the announcer say, this was really good for the Yankees because in situations like this, they're 14-5 in terms of winning the overall series. And then I went to bed and I woke up in the morning and it seemed to me, man, just by dumb luck, you ought to be better than 14-5, right?
Right.
A coin toss ought to do better than that. And so I decided to send a challenge to my kids, my sons, and son-in-law. And I just sent a note on text and said, look, I mean, this is what was said. What is the probability that, if each game's a 50-50 chance that the Yankees win the series? And the first one came back and he said, well, I used, such and such a model, and the answer is 78%. Okay. And I fired back to him, what? You didn't use pencil and paper and just figure it out analytically, right? And his response was, well, Dad, we're dicks, we're dirt and sticks unavailable, right? You had to use pen and paper, which I think, by the way, is a very, very funny line. And so I gave him credit for that, but then said, well, point taken. And I went back and tried a different model. Okay. And this model came out at 68%. All right. So one said 78%, and the one that said 68%, if you read the explanation, there were clearly errors in it. I tried one more, And this one came back with the answer 50%. And the last line is, which this makes intuitive sense because being up 2-0 conveys no advantage in the overall series. So,
Hmm.
clearly not correct at all. And by the way, the correct answer is 81%. All
Hmm.
right. And so all three models got it wrong. The first one, the one my son used, the mistake was a little bit subtle. The other two, it was egregious kind of thing, right? Now, what is going on here, right? Were the models fed not trained on this kind of thing? Were they fed bad data, right? So, I mean, the logic was there, but just the answers were wrong. How did they come up with this? And I've told this story to a lot of people, and they said, "Well, look, Tom, they're language models, not logic models."
Right.
And okay, well, sure, fine. Then how about coming back with the answer that ask a logical question? I'm not trained on those. I can't
Right.
help you,
Right.
right? Um, but again, I mean, so this is kind of where we are. What's going on? What were they fed? Not were they fed data that's not the right data? Were they not trained on the right data? Was the data they were trained on wrong? Right? Did they make mistakes even though they were trained on plentiful and accurate data? I mean, who the heck knows?
Right.
And and this example to me seems to crystallize where we are in a lot of artificial intelligence. I keep impeding the progress of artificial intelligence with a problem, which, look, this is not a high school problem, right? But it's also not a very difficult problem.
Yeah, well, you bring up an excellent point, which is when and how to use these technologies. And your friends are right that these are language models and they weren't really designed for math. But the challenge comes into understanding what kind of question is this? Is this a math question? In which case, to your point, it should say something like, oh, it's a math question. That's not really my strength. And that this is a question, though, for these people who are building these models. And one of my theories is that you're going to see new layers built into them, and it will have a math engine, for example, that will then route you in that direction. And it will have other engines. But I noticed, for example, if you asked ChatGPT or Gemini about anything political, it goes, oh, use Google for that. I don't touch that because they know
Right.
that it's not very good at these sorts of things. So and you might appreciate this. Everyone is trying to find ways to use these large language models. And I remind people they are probabilistic in nature, and they will always be probabilistic because they're taking text, for example, converting it to mathematical vectors, then getting their sort of landscape of what has been written out there. And then when you ask it for something, it converts the vectors back into text. Well, that is a lossy format, if you will, or a lossy process. You're going to lose integrity as you go through these channels. And I ask people, let's say it's 80% accurate. Well, what part of your business could be wrong 20% of the time? Not much.
Right.
Operations, finance, accounting, no, like that stuff has to be right, or at least darn near close to 100% right. So when I say that, people are like, oh, wow, gosh, that's a good point. We have to be careful about using this stuff. So you have to have guardrails and you have to know what you're using it for and when you're using it, right?
Yeah, well, so I don't think the quality is getting the attention it deserves. I mean, just as a little bit further background in quality, we kind of there's always two components to every quality problem, and that is, do you have the right data to solve the problem? And then the
Mm.
other is the data right? Now, there may be other quality requirements, like is it formatted in the right way? And so, like a barcode has some simple data in it, and it's formatted such that a scanner can read the data, kind of thing. And there's a lot of work, as best I can tell, in AI in creating these vectors, right? So getting the data in the right format. But then, well, have we trained it on a sufficient number of cases, right? Do we have all the right data we need? So we want this model and it's just a predictive model. We want it to work all over the world. Have we trained it on data from all over the world, right? Do we have that right set of data such that we can have some comfort that the model can at least cover it? And then is the data right? And our own studies show that a surprisingly high fraction of data just fails that. Is it right for basic operations?
Hmm.
It's our best estimate is about 3% of data sets meet is the data right criteria.
Wow.
And then, of course, in AI, we're looking at a lot of unstructured data, which we don't know, but we kind of presume is in worse shape than the structured data for which I just cited that statistic.
Hmm. Well, and so you get back to the point of data quality, and I think that the challenge here in business is that these tools, these large language models, ChatGPT, Gemini, Mistral, Claude, there's a whole bunch of them out there. They're so interesting and so powerful, we want to use them right away. But I think one of the challenges will be to get your data house in order before you start pointing these algorithms at your data. And luckily, these things are many of them are good, not necessarily large language models, but some of these foundational models are very good at classification. So classifying your data. There are cool companies like Shelf is one I've seen. Praxi Data is another that are scanning your unstructured data and giving you reports on it and saying, okay, this is incomplete data, this is redundant, this looks like this has some problem. That still requires manpower. It still requires people to sit there and look at stuff. So, what does the team look like? This, I think, is the big challenge as we embrace these new technologies. What does the workflow look like? What do the people do in these environments, especially with agentic AI? And I don't think this is a problem solved yet. I don't think it's a problem anywhere close to being solved. And I do think that the impetus should be on getting the information correct, making sure that our current systems are correct. And you know as well as I do, that's been a concern for 50 years.
That's
But
been a
now
concern.
it's
Right. I mean, let me
an
just build
acute.
on this. Right.
Yeah.
There are tools to help, but over and over, the companies that have solved the data quality problems, I mean, taking a level here and bringing it to a level there. The first thing they've concentrated on is getting the management right. Okay. And so the reason there's a lot of errors in databases is because people every day are creating those errors, or
Right.
machines aren't calibrated, or something is going awry and it's not being looked at, kind of thing. And so it's not necessarily the problem is in the system. The problem starts in our business processes, and then the bad stuff get captured in our systems. And so those that have solved that have worked backwards and figured out how they can say, okay, look, you're creating data. How do you know whether it's any good? Who are your customers? What are they saying they need? How do you measure it? When you come up short, are you getting to the root cause and making that root cause go away? And for the most part, Eric, I mean, these problems are not difficult, but companies are loaded with them, right?
Hmm.
They're loaded with them, and it's fine to say, we're talking here about AI, the impact on AI, but they affect company performance every day.
Hmm.
Uh, and so there's a lot of good reasons to solve them. But again, I mean, it's not going to happen if you think, okay, well, the problem's in the system, we're going to go clean up in the data in the system. Then 20 minutes later, you're going to have created a lot more bad data and have it again and again and again. And it takes a manager with a little bit of forethinking to say, okay, we're going to move upstream. We're going to attack the problem upstream.
Right.
And yeah,
And I'm glad you
most
used that term, right? Because that is an excellent term to use in terms of thought process and management protocol is go upstream. How far upstream can we go to focus on understanding the quality of our data? And you know what's cool is that these agents, so everyone's talking about AI agents. Salesforce just gave their big Dreamforce Agent Force launch, I guess it was called the other day. And it looks interesting. They have Atlas, I think, is their reasoning engine, and it's like the orchestrator of all the other agents. The agents do very specific things. And I think you can have a data quality agent that just crawls around your systems and goes, hey, here's a problem, here's a problem, here's a problem, give you the list of priorities to check on. I think that's where a lot of the value from AI is going to come is from suggestions from the agents. And then over time you try to train them to get better and better, say, no, that's not a problem, but this was a problem, the whole confirmation bias thing or rewarding it when it gets the assessment correct. But I think that those little recommendations and suggestions from the AI are going to become very important for helping us get the quality right. What do you think?
Well, I want to build on what you're saying and push back at on at the same time. So we've had plenty of good tools for a long time that help companies spot errors in databases. And whether they crawl around or you have some task force do it or whatever. The problem has not been finding errors. The problem has been getting people to fix them. And I mean, so you're shaking your head up and down, right? Well, it's no fun to come in every day and you have a list of, well, here's your 247 errors you get to correct today, Eric. Have a great day,
Right.
kind of thing, right? Furthermore, that never goes away, right? If you want the data quality problem to get, to go away, you have to say, okay, well, let's look at those 247 of them. And 196 of them are due to this problem. And 42 of them are due to this problem. There's a few of the others. Well, where are those 196 coming from?
Right.
Right. So I think the business of spotting the errors, right? So, okay, maybe AI can do that better than the business rules techniques companies have been employing. The trick is not to simply correct the errors. By the way, we make more data every day. Just play the movie forward, and before you know it, everybody's correcting errors every day, kind of,
Right.
right? And this is why it's a management problem. Left on their own, so people will fall into this, well, let's correct the errors trap kind of thing. The insight is that you have to start preventing them. And the good news I found, I mean, this, by the way, has been the best part of my career, is how much people love getting out and finding the root cause of an error and changing a process so that it goes away.
Yeah,
It
I love that. I think you're exactly right. Most people are problem solvers. We want to solve problems. Like once in a while you get an errant employee or contractor. It happens. It's pretty rare. Most people want to do the right thing, and when you encourage them, and this gets back to something you had said at the outset here, management, good management, having good managers help us get through this time is going to be really important. But folks, don't touch that dial. I'll be right back. You're listening to Inside Analysis. All right, folks, back here on a Inside Analysis episode with Tom Redman, the legendary visionary in our field, data quality. He's been talking about that for a long, long time. And I'm sure you felt blue in the face a couple times over the years. But now, at least, I think this just excitement around AI and Gen AI has at least raised awareness to get people to focus on cleaning out the closets, at least organizing the closets a little bit, to know what's in there, and that's good management practice. And I think that you've been around for a while in this industry, watching things change. The internet changed a lot. The cloud really maturing changed a lot. Analytics has been great to understand what's happening in some scale. And now with this AI stuff, it's like the whole world reflected back at us in text and imagery and so forth. Very, very powerful. But crazy things are going to happen here. We're hearing stories about millions of layoffs that could be coming because of automation and AI. I think we're starting to see some of that already, quite frankly, at Dell and Intel, and these big companies are laying off thousands and thousands of people. That's very disruptive. And I think to get us through that, we need really, really good managers. And I think good managers are underappreciated, but I hope that's going to come back and we're going to understand that good managers are great when they pay attention, when they help us through difficult times. That's what you're supposed to do as a manager, is get through the difficult times and temper the good times a little bit. What do you think?
Well, so look, I mean, as you properly noted, I mean, I've spent my career devoted to these data quality problems, and frankly, I've myself and some of my clients have enjoyed spectacular successes, where it's like $100 million got saved over here and $50 million got saved over there, and somebody created a competitive advantage for themselves over there, and so like there's plenty of points of light in the sky, but data quality's never caught on, right? For
Hmm.
most, it's kind of okay, well, garbage in, garbage out. We dealt with that, right? Now let's go to the next thing. Um, I think that it's really, really easy to underestimate how impactful anything that truly is transformative is.
Hmm.
And people have been talking about AI being transformative for quite a long time now, and they've been talking about generative AI being completely transformative for a couple of years, and most seem woefully unprepared to deal with the impact. Now, maybe what's in the back of their mind is, well, we know the data is not up to snuff. This AI stuff's not really going to work. Okay. And I think it's highly significant, Eric, that trillions have been invested in technology, right, for a long time. But still, magazines like The Economist say nobody's seeing the benefit on the bottom line. NVIDIA is, right, since Microsoft and some of those with models, maybe have, but not the companies that are using them.
Right.
Those are, and so I personally, I think that what is needed from managers now is much more of recognizing that this is not open process, insert new technology,
Right.
deal with the wetware, right?
Right.
Right, which
That's
is the
funny.
model that some, if you want to succeed with this, you're going to have to do way better with the data, right? And
Hmm.
you talked about that. You have to pull it together. You have to make sure you have the right stuff to train any particular model. You have to make sure that stuff is right, right? Maybe it evolves that you have hundreds of models trained in very niche areas and a few more general ones. I don't know the answer to that. And you have to make some really profound organizational changes,
Hmm.
right? And, so much of the things that we talk about data, by and large, we manage our companies up and down. But almost all of the interesting things with data happen this way,
Hmm.
horizontally, right? And until, right, managers and leaders, right, at all levels sort of deal with these organizational issues, I think it's going to be really hard for them to see a lot of success with AI. Right now, that doesn't mean some aren't going to go, okay, well, this can write all our code for us. We don't need all those IT people, right? Google's CEO announced the other day that 25% of the code they're writing now is being written by AI, kind of thing. And there's talk that it's like a radiologist, right? Very much a skilled profession that those people are gonna be put out of work. Let me say one other thing about it. I also think that that's what people said when the loom came in,
Right.
right? And instead, what happened was that we made far more fabric, right? Capacity went up, unit cost went down, and now I don't know what's going to happen. I don't know if we're going to be at the same level of production, just requiring fewer people. I think the promise is that the production is going to go up, right? I don't know what the fraction is. Maybe we make 10 times more stuff than we did before the invention of the loom. So what if we can make 10 times more stuff now, right? What if we
Hmm.
could, improve the human condition? What if a lot of really hard and noxious jobs became safer and paid more? And that to me is the promise, right? But that promise has no chance without way better data and a real fundamental think about organizational issues.
Yeah, in organizational processes, understanding what you can automate, what you should automate, how you automate it, how you track these things. It's very interesting. I think that you might appreciate this. I think that by and large, even though people are the innovators and they push things forward, a lot of times in organizations, especially big organizations, people are the bottleneck. Any given individual can be a tremendous bottleneck to slow down all kinds of things. You hear about these stories of big bets that are made on this decision or that decision, and they go south and everything falls apart. Big organizations are also hard to pivot. It's hard to pivot quickly. I mean, you mentioned Microsoft. I think Satya Nadella pivoting Microsoft to the cloud was probably one of the best pivots of any company ever, because up until that point, Microsoft was not thinking cloud. You still had these very large groups focused on Windows or focused on the Office suite and all this stuff. And then what happens? Google comes along and rolls out Google Docs and Google Sheets, and you can collaborate in real time. And I was like, how did Google beat Microsoft at the office computing game? It was just amazing what they did because they saw the future and they trained on the future. And I think what's going to happen is, to your point, I think these organizational structures are going to flatten out even more, but you will still have managers and stewards and liaisons, and they will be very, very important people in organizations to manage the worker bees and figure out how to change things and what to do differently going forward. But I think we're going to need a much more federated, decentralized architecture from the human side to succeed in the future. What do you think?
So, I mean, let me build on what you're saying a little bit. I mean, first of all, I mean, I think this, this notion of digital transformation is a misnomer. All
Mm.
the fundamental transformation happens between people's ears, right?
Mm-hmm.
And that's the first point I want to make. Second point is I think it's very popular to blame people, right?
Mm-hmm.
Okay, but my experience has been different. I see people doing extraordinary things, right? Without really good tools, without really good management, without really good leadership to get product out the door, to deal with bad data and so forth. So, the places I've seen quality improve, it's been about the people, right? And I just, managers maybe unleash them a little bit, or maybe it's just get out of their way in other cases. I personally, so my last book's called People and Data. And it's because I am excited about the potential for individual humans, right, to actually go out and make the transformation for themselves and make the transformation for their organizations.
Yeah.
Right.
Well,
So, I mean, sometimes I say it this way. I mean, it's popular to think they're part of the problem, and maybe that's true in some cases, but I know the only solutions run through people.
yeah. No,
Right.
that's true. I mean, it's a good point. People are, at the end of the day, what the company is all about. I got a friend of mine who worked in the music industry for a while, and he said when he got into it, he thought, "Oh, it's all about the music. It's all about the music," and he learned it's all about the people. And it's
It's
people
all
in your
about the people.
company. It's the people you work with, and of course, you want to build relationships and do more things with people. That's all important. But the people run the show, and the people are accountable at the end of the day. And it's like I like your knock on digital transformation. I've seen digital transformation happen a couple times now, and it's painful. I see these organizations thinking that some web app can do what the human always has done, like for hotel intake, for example. I stayed in a hotel in Austin, and it was all this online thing where I had to take a picture of my driver's license and do this whole thing on an iPhone, which I hate. I hate working on phones. I want to work on a keyboard with a
Right.
screen in front of me. I don't like working on the phone. And it was a very cumbersome, unpleasant process to get through this thing. And I'm thinking, guys, did it really cost so much to just have one person sit at the front desk and take people in? Like, is that really where you want to save the money? So, kind of back to your point, it is about the people, and we have to, and the tools can help with this too. Understand the flow. What is it that we're doing? Who does what where? At which point can we insert a person or a bot or an agent or whatever? That's an architectural conversation around business architecture. And I think there's going to be a bit of a renaissance around that and understanding and appreciating the importance of knowing the business architecture. Because a lot of times bosses don't even know the business architecture. What do you think?
Yeah. Look, I mean, I'm with you on that. I'm very much in favor of people enabled by technology. And obviously, look, I mean, we can't characterize it all one way or all another way. Some humans are going to get replaced. Some humans are going to drag their feet and they're going to get replaced because they drag their feet. Other humans are going to say, hey, there's opportunity here. I can distinguish myself and
Hmm.
and move forward. The last point I want to make in this is I kind of watched what happened after COVID, and and sort of like, people want to interact with people, right? We human beings, we are a social species, okay? And you interacting you interacting using your iPhone when you check into the hotel. Well, you just had this long travel and it was hard, it was rainy, missed a flight and so on and so forth. And you kind of want to get to the hotel and you see a smiley face, right? And I know you've had a hard day, sir. Here's a cookie, right?
Yeah.
Okay.
That's right.
And if you sort of reduce the interaction to, all right, well, all we did was check him in, right? You've missed the essence of the human to human thing.
Yeah.
Uh, and to your point, look, the technology aiding the person checking you in, right? Making that go faster, easier, that kind of thing, making it so, well, maybe rather than two of them, we only need one, and now you can get two cookies, right? With the extra money. I'm very, very much in favor of that. Okay.
Yeah. Yeah.
Uh, like, I mean,
I
I
agree.
I think that's I think that's where the future lies. And I do. I mean, again, nothing against the technology. I mean, I don't want listeners to perceive that we're being
Right.
Luddites,
Right.
right?
That's right.
Okay. Because I certainly don't feel that way at all. I think in this series, get the management right, get the people stuff right, get the data right, and you can do great things. And fail to get those things right, and it's going to be really, really hard. And then, you're going to blame people, you're going to blame things other than the technology when you, as a management team, didn't pull together the
Right.
factors that you needed to succeed.
That's
Uh,
right. No, that's exactly right. And I'll just throw out a quick anecdote along those same lines of digital transformation. And this gets back to strategy, understanding business architecture, understanding what you're trying to do, and taking care of your customers, because that's what you do in business is you take care of your customers, whether you're in food service, technology service, data service, whatever it is, your job is to help your customer with a product or service across the board. And I first saw this at YYZ Airport in Toronto where you didn't have a waiter come to your table. It was just an iPad in front of you, and you go and you select your food, and you do stuff like that.
yeah, right.
And then some server just drops it off. Well, now there's no relationship between the customer and the bartender or the waiter or the wait staff. And that's a big part of enjoying a meal, at least for a lot of people. For me, it is. And I felt like this kind of stinks. This like it took half the fun out of the process. Yeah, you might
Right.
be more efficient, but are your customers happy? And if they are, fine. Maybe that's a new mindset that you engage in when you go down that road. But for a lot of people, they want the interaction. They want to talk to a person. It's like customer service on the phone versus talking to some some vocal software agent, which drives me nuts. I can't stand having a I can speak in complete sentences, tell me what you're looking for. Right? I
Right.
want a human being to speak in complete sentences to me. Well, folks, look this gentleman up online, Tom Redman, data quality expert of years, and we're always glad to have you on the show. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, yours truly, Eric Kavanagh here, talking about all things data management, of course. We just heard from Tom Redman, a legend in the data quality space. He's been advocating for best practices around data quality for decades, for a pretty gosh darn long time, and with good reason. Data governance can lead to good data quality. Uh, Best practices in data management lead to good data quality. But let's face it, there are many, many, many factors that go into dealing with quality issues. And of course, much of my career over the past 2 decades has been focused on what's called structured data. Typically, that refers to data that's in a data warehouse, for example, in a relational database. That's typically what folks mean when they use the term structured data. Then, of course, you have all this unstructured data, or some people talk also about semi structured data. Well, unstructured data is like 80% of the data in an organization, sometimes more, it could be 90%. And unstructured data is everything from Microsoft Word documents to PDFs to PowerPoint presentations, lots of different files that have some kind of data in them. Of course, there is structure to these things. That's why some people refer to it as semi structured. But basically, you're talking about data that's not in a relational database. Well, that's like the context of all the structured data is the unstructured data. So to understand what the structured data means, you have to look at some of the unstructured data, which you can find in reports, for example, or like I say, presentations about revenue, projections, customers, whatever the case may be, there's a tremendous amount of context in unstructured data. There are also all kinds of issues around redundancy. I've heard that there's research that suggests that many enterprises on average will have 11 copies of data, of individual pieces of data. Well, you see that in the structured world too. A lot of times someone will pull a piece of data from a data warehouse into Excel and start playing around with it. Well, that is now a fork. It's now another piece of data that is reflective of other data in the organization, but is yet a separate entity, a separate file. Once you start making copies of things, you address, or you cause, I should say, a data governance challenge. Because if you get 10 people making copies of a piece of data and then they each make little changes to their piece of that data, well, how do you govern that? And the short answer is you kind of don't. So, why has this happened? Well, it happened for lots of reasons. One, because people wanted to play around with the data. It can be difficult to play around with data inside of a data warehouse. So a lot of times you issue a report, you'll run a report and then play around with it. You'll pull an extract of data. They talk a lot about sampling in this world too. Take a sample of data and play around with it to give yourself a good idea of what the whole data landscape might look like. Of course, sampling has its own problems. Sampling causes mistakes because maybe the sample you chose is not really reflective of the broader piece of information. Well, sampling was done because sometimes you can't run the algorithms you want to run on the entire data set. It's too expensive, it takes too long, it's just too cumbersome to do that. So you'll run it on little bits and pieces to get an idea. That's another factor that comes into play in data quality and data governance. And obviously, these two things are closely related. Good data governance ideally should lead to good data quality. But data governance, as of 10 years ago, was more of a wish and a dream. You could have some data governance policy, for example, that you would publish, but there's no guarantee that people would follow the rules. Now, these days, that's changing. In cloud environments, you can bake in policies and protocols and security authorizations and all these things. And then it becomes much more easy to understand who did what and when. Look at Google Docs as an interesting example. In Google Docs, and I was amazed when Google blindsided Microsoft with this ability to have multiple people collaborating on a particular document. Well, when you go in and use Google Docs, like let's say a spreadsheet or a word processing document, what happens? It tracks who did what and when, and there's an audit trail of who did what and when. This is very useful stuff. The lineage of activity on a particular file. Well, not all data is in the cloud. In fact, most data is still on-prem. And let's face it, on-prem environments are incredibly complex. You have all sorts of different storage arrays. You have different operating systems. You have different applications that are using data. You have different databases. So there are all these complexities that make that process extremely challenging, the process of data governance, the process of being able to audit who did what or when in that environment. Yeah, you can find it. You can look in to see who had access to which document, but it's just hard. It's just a difficult thing to do. It takes time and effort, and it's not a very fun job either, to say the least. Well, I said all of this as context for something that we talked about today on one of our other shows, The Briefing Room, which is a concept called a parallel file system. I'm still learning about these things, but it's very, very interesting stuff. It comes out of the world of high performance computing. So, the early days of data science, let's say, before we even called it data science, you had HPC, high performance computing. And they did a lot of interesting things with their technologies to be able to enable massive amounts of data to be analyzed. Think weather systems data, think life sciences data. With life sciences, if you're trying to understand the human genome, I mean, goodness gracious, that is incredibly complex stuff. And it's not data that it fits neatly into a relational table either. It's data that is amazingly dense. It's geometric data, it's biometric data. So there are lots of different aspects to it, which means there are many, many, many dimensions to the data. Well, when you think about compute power, if you're computing an equation that has 5 variables, for example, with X amount of data, okay, that could be a challenge. If there are 1,000 variables, that gets very, very difficult. It gets basically impossible. It gets very, very hard to get that computing done. So in the HPC world, they came up with this concept of a parallel file system. Well, one of the companies I've come across recently that has absolutely blown my mind is called Hammerspace. And Hammerspace has created a parallel file system that has fully abstracted out all the metadata about the files to its own layer such that it gets out of the data path, like where data actually moves. This does several amazing things. One of the fun side benefits of this environment is the data copy problem because they can overlay every one of your environments, every bit of storage that you have, whether it's on-prem or in the cloud, and in whatever cloud you want, in any of those environments, their system can overlay that environment and give you visibility into the files that are inside that environment. So, and not just block storage, for example, file storage, like the actual files. And this is a big deal for a lot of reasons. Like I say, the data copies issue is one, but really data access and data orchestration is the key. So I asked David Flynn, the CEO, before the show we did today, what he thought about data mesh. Like, how do you define data mesh? And he gave a bunch of amazing answers that I'm going to put into an article shortly. But basically, he came to the conclusions that I've come to, which is that I don't really know. I don't really know what it means. I had Jamak Degani on the show about a year ago, and she's a very, very smart lady. She is the one who coined the term data mesh. And now at her company, they're building out a technology to effect that vision. But nonetheless, before I had her on the show, I looked up on the Google machine, asked it for a definition of data mesh, and there were 25 different enterprise software vendors listed that had their own version or their own definition of data mesh. Well, something that has 25 definitions arguably has none. So it's very confusing to understand what that means. Well, the principles of data mesh are that you allow departments to govern their own data, for example. So in the old world, you could have their own database, maybe, and everyone else is using a different database. Well, that's not a very efficient way to do things. You would have to do all sorts of connectors and migrations and other things to be able to see a big picture. And that's why we did data warehousing in the first place, is to see a big picture of the numbers involved in your business, whether it be number of products, number of services, number of sales, number of people, whatever it is. It's numeric values that get crunched inside databases. The data mesh is supposed to be departmental, and it's supposed to enable the building of data products. Well, what we determined on the show today, before the show, in fact, was that we still don't really know what that definition of data mesh is. And David Flynn offered his take on it, which is really it's data orchestration. Data mesh is a data orchestration construct that gives the right pieces of data to people who want them at the appropriate time. And I mention all of this because I think that from a data management, data quality, and data governance perspective, what the folks at Hammerspace have done is truly remarkable. I mean, it's amazing, quite frankly. And I encourage you to look them up online and maybe check out some of the events that we've done with them. And the term Hammerspace itself is really kind of fun. The term Hammerspace refers to the space from which magicians pull things. So when a magician pulls a rabbit out of a hat, for example, he or she is actually pulling the rabbit out of hammer space. And that was the vision that they had, was to create this access layer. It's a global namespace is what they call it. And it creates this access layer that anyone can get the data that they want. It has to be orchestrated to them. So there's someone, I presume, who's going to be doing that, but they have both proactive and reactive ways of doing that stuff. And I think it's going to really help solve a previously intractable problem that affects data quality, data governance, and more. And with that podcast bonus segment coming up next. All right, folks, time for the podcast bonus segment here on a very fun and interesting inside analysis. We spoke to Tom Redman at the top of the hour, pre recorded that segment actually last week. He's been a legend in the industry for many, many years, talking all about data management practices, good practices to achieve high quality data. Well, one of the other hot topics we're talking about these days is quality data for AI. If you want to train your AI, if you want to train your own model, for example, if you're going to do a small language model and train it on your enterprise data, which I think is a very interesting concept. I think companies should not overlook this idea. And I know that because I've heard some pretty smart people talk about it. The CEO of Iterate, we had him on a show recently. They're doing that very thing. And the CEO of Mosaic ML, Naveen Rao, he was on the show a while ago. And in fact, right after Databricks bought them for like 1 point something billion dollars, billion here, billion there. Sooner or later, you're talking real money. We had him on the show, and he said the same thing. He said that we are trying to demystify the concept of building out your own models. Well, we've built AI models for years. There's a sort of traditional AI out there that some people talk about still, which is good stuff. You can have smaller models. They don't have 1 billion parameters, for example. They can have many fewer than that. But still, for certain tasks within the enterprise, that can be just fine. If you don't have that much data to input and don't have that many potential outputs or functions that you need to run, then you don't need 1 billion parameters. And there's something to be said for the complexity of large language models. They are large and they are unwieldy. And you don't typically need all those parameters to do various things. Now, they can learn tremendous things. It's kind of crazy what they can learn when you train them. And I managed to mention Hammerspace in the last segment. They are training Llama 2. So their company is actually in the process of training these large language models. Well, to do that, you got to do a lot of data orchestration. You got to do a lot of data movement. A lot of things have to come into play to make that happen. It's one of the things that they're doing. It's an absolutely incredible company. I encourage you to look into it. But back to the topic of data quality, I want to talk about something else that we're about to feature on another show on DM Radio later today, which is RAG, Retrieval Augmented Generation. And this is something that came out of Meta, and it's everywhere now. There are whole companies that are building out RAG models. So, what is a RAG model? Basically, it's a way to corner a large language model and get it to behave. It's really what they're trying to do. And what you do typically is you will put your data, your enterprise data, and you will enter it into a vector database. Now, remember, vector databases hold vectors. And when you train a model on your data, for example, your text, what you're actually doing is converting the text into mathematical vectors. And then when someone uses it, they do a prompt, it'll do a similarity search amongst all these vectors and then bring back to you a response that is based upon your prompt and the training that it has, which means it's going to decode and then turn those vectors back into text. Well, that process in the world, for example, of audio recording would be referred to as a lossy process, meaning you're going to lose some fidelity in the data itself when you go through that process because you're converting text to numeric values and then from numeric values back to text. So this is also why, for example, you'll often get a different answer from a large language model when you give it a very similar question. Why is that? Well, lots of different reasons. I mean, it's important to remember these models are incredibly complex. Neural networks are incredibly complex. And I should also point out OpenAI should probably be renamed closed AI because they are now a black box. They're a closed system. It is not transparent. It's not open source. Back in the early day when Elon Musk was involved, I believe the story is that he wanted it to be open. He wanted the whole thing to be transparent and open. I personally advocate for openness on these models. There is this whole issue of proprietary knowledge and proprietary techniques and so forth. I get that. But realistically, is someone going to come along and just become the next OpenAI? Mm, it's pretty hard stuff to do. And even if it is all open source, still understanding these models, even when it's transparent, is excruciatingly difficult. It's one of the challenges. One of the reasons why they hallucinate, because we don't really know what's going on underneath the covers there, which is kind of scary stuff. So we talked about data quality, data governance. Where does all this come into play? Well, I will tell you, it is very important to remember that these foundational models like ChatGPT and Gemini and Claude, they are probabilistic, going back again to the conversion of text to numeric values back to text. It's a lossy process. They are probabilistic. They are not deterministic. An ACID compliant database is deterministic. When you do a query on a database like that, it's going to show you exactly what's in its repository based upon your query. So that's why you use SQL, the structured query language, to get into the database and understand, all right, what's actually going on inside of there. It's deterministic as opposed to probabilistic. So I think that there are many mistakes being made now in terms of how these technologies are being used, these foundational models, and we need some education. We need people to appreciate the difference between deterministic and probabilistic. There's a big, big, big difference. And to drive that message home, I'm going to give you this one question, and I need to finally write an article about this. Which part of your business can be wrong 20% of the time? Sales, operations, fulfillment, accounting? No. Like that stuff has to be right. Can you imagine if every time you ordered from Amazon, there was a 20% chance you'd get the wrong thing? I don't think you'd be ordering much more from Amazon if it had even a 10% error rate. Even a 5% error rate is pretty rough. Getting the wrong thing 5% of the time, maybe you can survive, but it's going to be difficult. So the point being, these large language models in particular are very good at expediting processes. So they're very good at the co-pilot use case, helping you write 80% of your code, helping you write 80% of your press release, helping you write 80% of your article if you want to go down that road. Okay, but do not think that you can trust them to get it 100% correct, because you can't. And I've seen webinars with Andrew Ng, one of the most prominent speakers and thinkers in the space, who got excited about getting a model from 80 to 85 to 90% accuracy. Again, even at 90%, it's going to be wrong 10% of the time. That is no bueno for many enterprise use cases. So just keep all that in mind. Well, folks, it's always fun to have these shows and to talk to you about what's happening in the industry. Send me an email if you want to be on the show, info@insideanalysis.com. We'll talk to you next week. You've been listening to Inside Analysis.